In this video, we will be solving rational equations such as these. Now, first I'm just going to spread this problem out a bit so I have room to work. So I have 2x over x plus 1. Leave a little space there. And then I have 3 over x minus 1. Leave a little space there. This is bothering me. I'm just going to leave it for now. So I have 15 minus x over. I am going to factor this. This is the difference of two squares, which is x plus 1 times x minus 1. Now, I'm going to do this problem by using like denominators. So I want all the denominators to be the same. I see this big old denominator has x plus 1 and x minus 1. This has x plus 1. It only needs x minus 1. We'll have to put the same thing in the numerator and denominator. That way I'm really multiplying by 1. Anything divided by itself is 1. This denominator has x minus 1, so it only needs the x plus 2. So I'll put a whoops. No, did I say x plus 2? It only needs x plus 1. So I'm going to put x plus 1 in the numerator and the denominator. Alright, now the denominators are all the same. So here's the trick. If the denominators are all the same, then that means the numerators must add up to be the same thing. In other words, you can really disregard the denominators and just look at the numerators. Okay, so that means I have 2x times x minus 1, alright, that's just the numerator, plus 3 times x plus 1 is equal to 15 minus x. Alright, I'm just ignoring the denominators. Doing the distributive property gives me 2x squared minus 2x plus 3x plus 3 is equal to 15 minus x. Okay, combining like terms. I see the 2x and the negative 2x and the 3x, that's just x. So I'm going to have 2x squared plus x, right, combining those, plus 3 is equal to 15 minus x. Looks like I'm going to need to get everything on one side. Yeah, I'm going to get everything on one side. So I am going to add x to both sides, and I'm going to subtract 15 from both sides. Let's see what I get. So now I have 2x squared plus 2x minus 12 is equal to 0. So I just need to solve this equation. I'm noticing there's a common factor of 2. So it would be in my best interest to factor out the 2. So that would be 2 and then x squared plus x minus 6 is equal to 0. Now I could keep this over here, or if I wanted to simplify things a little bit, I could divide both sides by 2 and cancel out those 2's. 0 divided by 2 is still 0. So now I'd have x squared plus x minus 6 is equal to 0. Alright, just simplifying things. Now I can factor, hopefully. So x squared will just be x times x. 6 is going to be 2 times 3. Inner plus outer must equal the middle. So inner, I have 2x. Outer, I have 3x. I'm trying to get a positive 1. This is like a positive 1. So I need a negative 2 and a positive 3. So there's my negative 2, there's my positive 3. A negative times a positive will give me negative 6. So this is working. Alright, so now that I have factored, it's time to set these factors equal to 0 to get my solutions. Alright, so x equals 2 or x equals negative 3. Alright, as long as those are not excluded values. So let's look back and make sure that they are not excluded. So remembering that this is x plus 1, x minus 1, these are the restrictions. Okay, looking at the x plus 1, that tells us that x cannot equal negative 1. Looking at the x minus 1, x cannot equal positive 1. I'm setting these equal to 0 and solving. So these are my restrictions, and these are my answers. So neither one of these is restricted, so we're okay. Okay, so that was number 5. Let's do number 6 in the same way. Alright, so I'm going to factor this as I write it down. So I have 7x plus 3 over, okay, x squared is x times x. 15 is 3 times 5. Alright, inner plus outer must equal the middle. So I have 3x and 5x. To make negative 8, these both have to be negative. A negative times a negative does give me positive 15. So this is working. Okay, so we factored that. Great. So anyway, so I have plus, and this is 3x over x minus 5. Alright, I'm going to leave a little space here and put negative 1 over x minus 3. Now, using the like denominator method, I see that these have x minus 5 in common, but this denominator has x minus 3, so I'm going to give this denominator x minus 3. You have to do the same thing to the numerator, though. Now, everybody has x minus 3, but this denominator is lacking x minus 5. So I'm going to put in an x minus 5 in the numerator and the denominator. Now all the denominators are the same. Once you have all the denominators the same, you can ignore them. Okay, and just set all the numerators equal to each other. So at that point, alright, just looking at all my numerators, I've got 7x plus 3 plus, now I'm going to go ahead and distribute this. 3x times x is 3x squared. 3x times negative 3 is negative 9x. I'm going to distribute this too. So that'll be negative x plus 5. So let's see, like terms. 7x and negative 9x are like terms. But first I'm going to put my 3x squared. Alright, I'm just bringing that down. Now 7x and negative 9x, that's negative 2x. And then I've got the 3, so I'm just going to bring down the 3. I'm writing it in standard form as I go. And then I've got my negative x plus 5, bringing that down. Now I'm going to need everything on one side. So I will add x to both sides and subtract 5. So that's going to give me 3x squared minus x minus 2 is equal to 0. Now I'm betting this is going to be factorable. So let's give it a shot. 3x squared can only factor as 3x and x. 2 can only factor as 1 times 2. Probably should have done it the other way. Inner plus outer equals middle. Inner, I have 1x. Outer, I have 6x. I'm trying to get negative 1. There's no way to get negative 1 out of 1 and 6. So that's what I saw coming when I said I probably should have done it the other way. So I'm going to turn around and put the 2 here and the 1 here. Inner plus outer must equal middle. Inner, I now have 2x. Outer, I have 3x. To get a negative 1 middle, I will need a positive 2 and a negative 3. So there's my positive 2, and this will give me negative 3. A positive times a negative will give me the negative 2. So this is working. To get the answers, I need to set both of these factors equal to 0 and solve. So subtracting 2, I have 3x is equal to negative 2. Dividing by 3, I have x is equal to negative 2 over 3. Adding 1 to both sides, I have x equals 1. Alright, these are my solutions as long as they are not restricted. So let's look back and see. Okay, so looking at these denominators, alright, looking at the x minus 5, that tells me that x cannot equal positive 5. Looking at the x minus 3, that tells me that x cannot equal positive 3. These are my restricted values. Looking at this, remember it just factored down to the same things. Alright, so neither one of these are excluded values, so these are the solutions to number 6. Okay, let's go ahead and do number 7. Okay, I'm thinking ahead. When I see this 3x plus 6, I'm seeing a common factor, a GCF. And I'm thinking ahead about whether or not it will cancel anything out. And I think it will, and you'll see why. So I am going to factor out the GCF as I write this down. So I'm going to have 3, and then I'm going to pull that out, and that will leave x plus 2. Alright, I pulled out the GCF. Now, x squared minus 4. Now you're about to see why I pulled out the GCF, because x squared minus 4 factors as x minus 2 times x plus 2. Alright, the difference of two squares. Okay, now that is going to equal this, and I'm just going to copy it down. So I have x plus 1 over x minus 2. Okay, so because we have these like factors in the numerator and denominator, these are going to cancel each other out. Alright, so they're gone. So now I have 3 over x minus 2 is equal to x plus 1 over x minus 2. Oh, well, that's nice, because I want the denominators to be the same, and they already are. So we know that once the denominators are the same, we can ignore the denominators and just look at the numerators. Okay, so 3 must equal x plus 1. Subtracting 1 from both sides is going to give me 2. So 2 is equal to x is equal to 2. So this is the solution as long as it is not a restricted value. I think I see a problem coming. Looking at these denominators, x plus 2 and x minus 2, all right, even the one that cancels out counts. All right, so if I set x plus 2 equal to 0, I get x equals 2. That tells me that x cannot equal 2. If I set x plus 2 equal to 0 and solve, that gives me x equals negative 2. That tells me that x cannot equal negative 2. So these are my excluded values, 2 and negative 2. But look, the solution that I got is one of the excluded values. So this value is called extraneous. All right, if your solution is one of the excluded values, you cross it out and you put extraneous is the word that describes that. And that means that there really is no solution. And so that's really what you have to put for your answer, is no solution. Okay, let's put a box around that. Okay, so you might be wondering, so which one of these things do you put on the answer line? The answer is no solution. And the reason why it's no solution is because 2 is an extraneous solution. So you need to know that vocabulary, because that might show up. But if I just give you a problem and you're supposed to solve it, the answer would be no solution. All right, let's do one more problem. And it looks relatively peaceful, except for it has 4 terms, which is a little weird. Let's see, do I even need to space this problem out, or are we good? I think we might be able to do this without even spacing the problem out. I want all the denominators to be the same, okay? But I really only see one denominator, x. Okay, so I want all of the denominators to be x. So I'm going to put an x everywhere, but every time I do that, I've got to put one in the bottom and the top. So x, 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 x. Okay, so now all of the denominators are x. Once the denominators are all the same, you can ignore all the denominators. Okay, so I'm canceling the denominators out. So just look at the numerators. So I have 15 minus, and x times x is x squared. Okay, and then plus 8x is equal to 10x. So that's what I have now. There are no like terms here, so I don't really have to worry about that. So I'm going to subtract 10x from both sides. Now when I recopy this, I am going to write this in standard form. So the negative x squared will go first. 8x minus 10x is going to be negative 2x. And then I've got the 15, so I'm going to put my plus 15 on the end. Now I want to try to factor this. This is a 0. I want to try to factor this, but it's not good to try to factor when you have a negative in the front. So what I would do is I would factor out that negative 1. Look, another way to think of it is you're allowed to divide both sides of the equation by any number other than 0. So I'm going to divide the left side of the equation by negative 1, and I'm going to divide the right side of the equation by negative 1. I'm just going to divide through by negative 1. That's allowed. So that's going to give me x squared plus 2x minus 15 is equal to 0. All right, now I'm going to try to factor it. X squared is x times x. 15 is 3 times 5. Inner plus outer equals middle. Inner I have 3x, outer I have 5x. To get positive 2, I need a negative 3 and a positive 5. So negative 3, positive 5. A negative times a positive will give me negative 15. So this is working. To get the solutions, I need to set these factors equal to 0. So x minus 3 is equal to 0. X plus 5 is equal to 0. Alright, so adding 3 to both sides, I get x is equal to 3. Subtracting 5 from both sides, I get x is equal to negative 5. So these are the solutions as long as none of them are restricted. Okay, so looking back at the original problem, I really only have one thing, one variable in the denominator, and that is x. And you can't divide by 0, so x cannot equal 0. That's my only restriction. And that's not what I have here, so these answers are fine. So that is it for number 8. Alright, that's the end of this video. I hope it was helpful. I'll see you on the next video, whenever that may be.